In this video, we review the basic features of the AutoCAD Hatch command. Hatch is an AutoCAD-specific term, which simply means to shade. The architectural term often associated with hatch is poche. The hatch command adds patterns to floor plans, walls, and detail drawings to add clarity to the object it references. In this example, the hatch pattern helps to provide meaning to the flooring material for the interior design. In this example, the hatch pattern provides very specific definition to the type of wood grain used on the cabinet panel. These two examples show very different methods of constructing the recessed cabinet panel of a framed cabinet style. Finally, solid hatching is often used to fill in the exterior wall lines on floor plans to add visual hierarchy and clarity. In the example shown, there are 4 rectangles set up to demonstrate different aspects of the hatch command. Adjacent to the rectangles is a plan view layout for practice shading walls and floor areas. Let's get started with an introduction of the hatch command and the specialty ribbon that helps define hatch patterns in AutoCAD. At the command line type, hatch, return Enter key. This command deploys the specialty hatch ribbon in AutoCAD at the top of the drawing environment. On the left side of the hatch ribbon, there is a boundaries panel. Boundaries are the most important aspect of creating a hatch pattern. On this panel, you have the option to select a boundary or to pick inside a defined area. The pattern panel is adjacent to the boundaries panel. On this panel, you can visually see examples of different pattern types. This panel will dynamically change and update to offer different choices from the pull-down menu, accessed by the white arrows on the pattern panel. From the pull-down menu, you can choose solid shaded fill types, gradient fills that mix 2 colors together, and user-defined hatch patterns. User-defined hatch patterns are those that are purchased from third-party vendors and have been installed to be used with the hatch command in AutoCAD. Adjacent to the pattern panel is the hatch property panel. This panel allows you to see at a glance current settings such as the hatch pattern, layer, background color, transparency value, angle, and scale. The hatch origin panel is adjacent to the hatch properties panel. This panel allows you to choose where the pattern repeat begins, in reference to a point you pick on the object. There are 7 different options for setting the beginning of the hatch pattern in the pull-down menu on the origin panel. The hatch options panel is adjacent to the hatch origin panel. The options panel allows you to set whether the hatch will be associative, which means to be grouped and retains the ability to be easily modified. The options panel also indicates an annotative option, which means when this is selected, the hatch pattern automatically scales up or down depending on the viewport drawing scale. The last thing on the options panel is the hatch match properties command. This is very useful when you need to match the scale and layer of a pattern within the existing drawing. Finally, the close hatch creation checkmark is the button that closes the hatch command choices. We are now going to practice the hatch command in the 4 rectangles. In the first rectangle, choose a hatch pattern such as the pattern entitled Net. Scroll down to find the net pattern. From the boundaries panel on the hatch ribbon, choose Select Object. This means that we need to pick the rectangle as the boundary. As soon as I pick on the rectangle, hatch fills the area, but it doesn't look like the net pattern. Why does it look like a solid fill instead of a pattern? The answer is that the pattern scale is so small that it appears as a solid fill instead. There are many patterns such as net in AutoCAD Hatch where you will need to increase the pattern scale in order for it to make sense in the drawing. Let's increase the scale to 12, which increases the scale to what we might perceive as a full increment in the imperial system of 12 inches equals 1 foot. 12 is always a good starting point for increasing the scale. Since the pattern is still too small, the next increment I will try is times 10. I will change the scale value to 120. This now appears to be more recognizable. We have now made an industrial design hatch pattern into something we can use in interior design. This somewhat resembles a tile pattern. If we were using this hatch pattern in a room, we would want to reset the origin point of where the first whole tile appears in the space. Let's go to the origin panel and pick a new origin, or starting point for the pattern. From the origin pull-down menu, choose the bottom left-hand corner option to start the pattern repeat. Now, pick the Set Origin button. This allows you to show AutoCAD where on the object you want the pattern to begin. Move down to the rectangle and pick in the lower left-hand corner. Notice how the pattern instantly realigned to the pick point. Now let's look at where this pattern is located. By default, it has been placed on the A-floor pat layer. This was set up for you in the practice assignment file. Layers are an important way to control how we view the hatch pattern, and must be located on a unique layer such as those defined in the AIA Layer Standards handout. Pick on the Close Hatch Creation, on the green check arrow to end the command. Moving on to the next example, we will create a solid fill pattern. Always use a solid fill if you intend it to be used as a shaded area. Never use a pattern defined at a tiny scale in a big area, such as a room. This will take a lot of your computer's memory to generate the hatch pattern repeat over and over. Instead, use a solid fill if you want an entire area shaded. Start the hatch pattern again for the second rectangle. On the hatch pattern panel, locate and pick on the solid pattern. Browse the pattern bank from the white pull-down arrow if you do not see the solid hatch fill. Scroll up to locate the solid fill pattern and pick on it. Next, on the hatch boundary panel, pick the select option again as we did in the first example. Pick on the second rectangle. The solid fill appears in the rectangle. The fill color is gray because of the layer color assignment. To understand why the fill is this color, go to the Hatch Properties panel and pick on the Properties down arrow. You can see that the current layer is A-floor pat, and the color assignment is Index Color 253. Pick on the Close Hatch Creation, on the green check arrow to end the command. Start the hatch command again. This time we will use the linear gradient fill. In the third rectangle, locate the linear gradient fill in the hatch pattern panel. As we did in the first two rectangles on the hatch boundaries panel, pick the select button. Next, pick on the third rectangle. You will see the standard blue and yellow linear gradient fill up the rectangle. On the hatch properties panel, pick on the white drop-down arrow for gradient fill number 1. Choose any color that is not the same blue. In the gradient fill number 2 drop-down arrow, choose any color that is not the same yellow. Notice that the gradient blend changes to the colors you selected. While still on the hatch properties panel, locate the angle field. Pick on the value field where it is currently 0 degrees. Type in a different value such as 45. Finally, go to the properties panel white arrow, and change the layer designation from A-floor pat to A-pat. The gradient fill is now on a different layer than the first two rectangles. Pick on the Close Hatch Creation, on the green check arrow to end the command. For the final rectangle, we start the hatch command again, and this time we will locate the Dalmat pattern from the Hatch Pattern panel drop-down menu. Once you have found Dalmat, from the Hatch Boundaries panel, pick the Select button. Pick on the fourth rectangle. You will see a hatch pattern that looks similar to a plank flooring pattern. Pick on the Close Hatch Creation green arrow to end the command. A common plank width is 8 inches. Let's see how the Dalmat pattern in rectangle number 4 compares to this standard. By measuring the distance between the plank lines. It is difficult to measure the exact size of the planks because the pattern is associative in nature, meaning it is a block of information. To be able to make an approximate measurement using the distance command, toggle off the O-Snap F3 button for a moment. Zoom up close on the hatch pattern. Use the distance command to pick 2 points for an approximate measurement. The pattern repeat does not have to be exact, because we will also specify the exact width of the planks for estimating and procurement on the construction documents. Try to approximate pattern repeat close enough in scale to illustrate the design intentions within the drawing. At the command line type, Hatch Edit. Return Enter key. Pick on one of the lines of the Dalmat pattern in rectangle number 4. The Hatch Editor dialog box will deploy onto your screen. In the Hatch Editor, you can see a variety of different options which you can use to modify an existing hatch pattern. You can even change the pattern within this dialog box, if needed. However, we just need to reduce the scale of the Dalmat pattern down to a scale factor of 32. Pick the OK button. Take another measurement of the planks using the distance command. This time the plank width is pretty spot on to the 8-inch pattern repeat required. The next example illustrates the process of applying the Dalmat pattern to the plan view drawing using the Hatch Match Properties feature on the hatch ribbon. The first critical aspect of this example that requires attention are the openings between the wall lines, where doors and windows would be located. The hatch command creates a repeatable pattern only when there is a closed boundary. Any open spaces will create an error using Hatch. To prepare the plan view for Hatch, make sure the A-floor pat layer is current. Next, use the line command to make a boundary by picking on the interior side of the wall lines using the OSnap endpoint. Go around the entire plan view, closing all gaps and openings. This is an essential tip when using the Hatch command in drawing views, such as floor plans. Once the plan view is prepped for a hatch pattern, pick any pattern from the Hatch Pattern panel. Since we are matching the pattern to the existing Dalmat hatch in rectangle number 4, it doesn't matter which hatch pattern we initially apply here. From the Hatch Boundaries panel, we are going to select Pick Points. This selection method works by picking on an interior point of an area of a closed region. As soon as you pick the interior point, AutoCAD fills the area with the pattern until it hits each side of the boundary. Once you have placed the hatch pattern, employ the Match Properties tool on the Hatch Options panel. Read the command line prompt. Pick on the Dalmat pattern in rectangle number 4, and then pick on the hatch pattern in the plan view drawing. The pattern in the plan view drawing should now match the Dalmat pattern and scale from rectangle number 4. Pick on the Close Hatch Creation on the green check arrow to end the command. The last example of using the hatch pattern involves shading the exterior wall lines using the solid hatch pattern. To prep the walls for the solid hatch, make the A-wall pat layer the current layer. This layer has a different pin assignment which defines the value of the shading. It is essential that all of the wall lines be connected so that each section of the wall is a closed region. If any part of the wall lines do not connect, the hatch pattern will denote an error. Start with the Hatch command. Locate the solid fill on the Hatch Pattern panel. On the Hatch Boundaries panel, use the Pick Point Selection tool. Zoom up close to the wall lines, but make sure you can see the entire closed wall area on the screen. If you are zoomed in too close to an object and parts of the region are not visible. Sometimes, AutoCAD cannot perceive the closed boundary until you zoom out just enough for the entire bounded area to be visible. Practice zooming in and out of the plan view, as well as use the pan hand to move the drawing into view each time you pick on a point inside the wall lines. When all of the exterior walls have been filled with the solid hatch pattern, pick on the Close Hatch Creation green arrow to end the command. Toggle over to the 11 by 17 inch sized paper space tab. On the 11 by 17 paper space tab, create two viewports using the Multi-View command. Make sure that the viewports are located on a non-plotting layer, such as def points. Next, set the drawing scale for the Hatch Practice viewport depicting the 4 rectangles at 1/4 inch scale equals 1 foot, 0 inches. Set the Hatch Practice Plan View viewport to 1/8 inch scale equals 1 foot, 0 inches. In the adjacent title block, double-click anywhere on the title block information to edit the attribute text. Attribute text is specialty text that can be edited within a block or right block. To edit any part of the attribute text, highlight the field, and then type new information in the value field. When you are done editing all of the attribute text in the title block, then pick the OK button to exit the attribute text editor. You will need to utilize the block editor command in order to change the name and email address to your own, since this area is not attribute text. If you have created a logo, replace the text "Your logo" with the logo graphic. If you do not have a logo, you may erase the tag for the logo in the block editor. Save any changes you make in the block editor. Then create a PDF file of this assignment using the monochrome. CTB pin assignment. Follow the principles of using the AutoCAD Hatch command in all project assignments where Hatch is a requirement.